Okay, so hopefully you've tried out this problem here, played around with it a little bit to see, does it seem like it's possible to add a fifth point to my 4 points here in such a way that none of the midpoints have integer coefficients? And we could try to guess and check a little bit to see. Clearly nothing nearby is going to work, right? If I chose this point up here, then the midpoint between these two would be this one with integer coefficients. If I chose this point here, similarly the midpoint between these two has integer coefficients. We've already talked about why 2, 2 wouldn't work, right? Any of these guys, we're going to have an issue with something that's 2 units away. So we might try some things that are even further away just as a method of guess and check. Maybe I try something out here at 1, 2, 3, comma negative 2. Does this work? Oh, no, this isn't going to work because these 2 points together have a midpoint that's integer coefficients. Okay, so try some other things. Maybe try something up here. Oh, no, negative 2, negative 2. Positive 2 won't work because it's going to have an integer or a midpoint right here at integer coefficients. And guess and check seems to suggest to us that this is not going to work. But the question is, why? How can we try to leverage what we know about pigeonhole principle to prove that there's never going to be a fifth point that you can add? Even if we started with a different 4 points, there's never going to be a fifth point that you can add. Right, so let's think about why. Well, to start with, it might be useful to remember what the midpoint formula is. So given 2 points, let's say x1, y1, and x2, y2, the midpoint of the line segment connecting these two is given by the formula essentially we just average together the x coordinates and the y coordinates. So we add x1 plus x2 and divide by 2. We add y1 plus y2 and divide by 2. Okay, so if we go back to our picture for a second and think about the issue that we were having here, right? When we chose this point here at 3, negative 2, it caused a problem with this point here, right? Because the midpoint would be, let's see, the x coordinate would be 1 plus 3 divided by 2. 3 plus 1 is 4 divided by 2, and the y coordinate would be 0 plus negative 2 divided by 2, right? This midpoint would be 1 plus 3 over 2, comma 0 minus 2 over 2. This is 4 over 2 and negative 2 over 2. So the midpoint is at 2, negative 1, which is integer coordinates. The issue here is this is going to be an integer whenever the number on top, your x1 plus y1, is even, because an even divided by 2 is going to be an integer. And whenever y1 plus y2, with the y coordinates, the top of this second fraction, is even, because an even divided by 2 is an integer. Okay, and so what we need to consider here is the fact that if x1 plus x2 is even, then x1 plus x2 divided by 2 is an integer. And the same thing is going to be true for the y coordinate. If y1 plus y2 is even, then that second y coordinate will also be an integer. So we need to make sure when we're choosing our points that the x coordinates added together are not even, or the y coordinates added together are not even. If they were both even, if x1 plus x2 was even and y1 plus y2 was even, then that midpoint would have integer coordinates. So what kinds of numbers when you add them together are even? Well, we've talked about this in different contexts in this class, right? For example, let's say you chose a point that had an even x coordinate and an even x coordinate. We know that an even plus an even is going to give you an even, which means our second point, if it also has an even x coordinate, can't have an even y coordinate, since even plus even is even, and if we had another even here, the y coordinate would also be even. So we could choose another point which is odd, And then these two coordinates added together would give you something odd. And when you divide it by 2, you will not get an integer. Right, so for example, we started by choosing 0, 0, and 0, 1. Right, the midpoint between these 2 points, put lines through my zeros just to differentiate between zeros and O's for odds. Right, so the midpoint between these 2 points was at 0, 1/2, which was fine. And then similarly, we can choose a third point such that it doesn't match up, right? So if we had an odd and an odd, then an even plus an odd gives you an odd number, which means your x-coordinate of the midpoint between these 2 points would not be an integer, which is good. And in the second case, an odd plus an odd isn't even, but an even plus an odd is odd. And so the x-coordinate for the midpoint between these 2 points is also not going to have integer coordinates. Okay, and in the last case, we could have an odd and then an even, and we can see that these 2 points will have a y-coordinate, which is not an integer. These 2 points would have a y-coordinate that's not an integer because odd plus even is odd. And for the first and the last point, the x-coordinate will not be an integer because even plus odd is odd. Right, and this is exactly what happened with the points that we chose. We chose 1, 1, and then we chose 1, 0, and these all satisfy that they have different parities of their coordinates. They had even, 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 odd, 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 and odd, even. Now the problem is, if we were to add in a 5th point here, it's going to be a repeat of one of these 4 parity pairs, right? It's either going to be both even or an even odd, or both odd or odd even. So any 5th point will have the same parity as one of the 4 points already chosen. And we know that by the pigeonhole principle, because there's only 4 pigeonholes, and now we're choosing a 5th point. Once we've chosen that 5th point, let's say it's another even, even, then these 2 points together will have a midpoint with integer coefficients, because an even plus even gives you an even. You divide by 2, it's an integer, and the same thing for the y-coordinates. And if your 5th point was in this case, it'd be the same idea, right? Odd plus an odd is even, and so the y-coordinates would also be integer, would also have an integer coefficient. And for any one of these, right, whichever one you choose for your 5th point, that point that has the same parity is going to give you a midpoint with integer coordinates. Okay, so pigeonhole principle is what allows us to conclude that we can't add that 5th point. So it's impossible. Okay. Now you might want to think about how would this generalize to the 3-dimensional case, right? If we have 3 space and we have, I'm not going to try to draw it, I'm not going to draw it, right? How many points could you choose so that the midpoint between any of the points you choose does not have integer coordinates, right? It's going to be at least 5, I think. It's going to be more than 5, right? You can now add a 5th point, let's say, somewhere up here, right at 1, 1, 1, and it's not going to have, just draw it up here, and it's not going to have a midpoint with integer coordinates for any of the chosen points so far, right? So it'll be at least 5, but in fact you can choose more than that, and I'll let you think about how that might work if you generalize to more than 2 space.